Hi there once again, and welcome to another Expresso mechanic tutorial. And this is the third and final part in my series on building a scissor lift. And in this one we're going to be focused on building the control system. So we're going to use a combination of Expresso, Python and of course some user data in order to create these buttons which are going to allow us to control the lift when we run our timeline. So we'll be able to lower it, we'll be able to raise it, and we'll be able to stop it as and when we choose to. So that's what we're about in this tutorial. So without further ado, let's see if we can make this happen. The first thing we need to do is select our controller, go into our user data here, and we'll add user data. And we'll call this buttons, and what I'm going to do, I'm going to just drag this data into here and rename it buttons. And then we'll add an integer for the data type. The interface will say radio buttons. So we need a value and we need a string. So we can say 0 for our first value, semicolon, and we'll say raise for the string. Second button will be 1 for the value, lower for the string, and then finally it will be 2 semicolon stop. And that's our buttons done. And if we go into our example here, it shows us what they're going to look like, and that's perfectly good. So we can OK the result, and we're now there. The one thing we can also do, if we go back into our user data and we say manage user data, we can now remove the controller. We don't need that anymore, so we can take that away. It served its purpose. Right, that's great. So that's our buttons done. The next thing we can do then is think about adding an Expresso tag to our controller. So we'll come down to Programming Tags, Expresso, and we're ready to start work. Before we start building the expression for the controller here, I'm just going to go into the scissor lift. And where we've got controller here, you can see it now says undefined. It's because we've taken away that user data. So what we need to do is say coordinates, position, and it will be position X. That's what we're going to be using in here now. So let's just move this out of the way and make the window a little bit bigger so we can see what we're doing. Yeah, so all we need to do is plumb this into this input here. And now we can take away the undefined port, and we can also plumb this into the math add and the float function. And now everything will work again. That's fine. That's sorted that out. It's ready to go. Next thing to do then, we can start looking at the controller. So we'll click on there and we can start working out what we're going to put in here. Well, for a start, we're going to drag the controller itself in, come down to controls and select buttons. And we're also going to use the position X here too. So we've got those two in. We now need a time node, because obviously we're going to be using the timeline for this. And as per usual, I'm going to delete the time port and add a frame port. That's got those two ready. The next thing actually is to drag the controller in again, and at the input stage this time, coordinates position X. And now we're ready to go. And then to bridge the gap between all of these, we need the all-important Python node. So come down to Script, Python. Take away all of the ports. And we're ready to develop this from here on. The first thing to do with our Python node is to give it some ports. So we'll start with an integer, and we will rename the port frame. Another integer, and this time we will call this button. And finally, at the input stage, we need a real value. So we'll put one of those in as a float and rename the port, and we're going to call this C pos X. So it's C for current, the current position X of our controller is what we're interested in there. make this a little bigger. And at the output stage, we just need another float. And we will call this. Oops, I've just deleted the port. Don't want to do that. Stand that back in. It's going to be another float value. And we'll rename that. That's what we want to do. Pos X. Okay, so we're all set up. So our frame port we can plumb into the first input, the buttons into the second input, and finally the position X down at the bottom there. And the output can go here as and when it needs to. If we go into our Python node, and I'll change to a scripting layout, open that up again, go into my Python node, and open in the Python editor. We're ready to start work. I'm just going to close this down for a minute. Select Python in here and clear this out. Actually, before I go any further, I'm just going to open this up and I'm going to rename a couple of these ports just for the sake of doing things the way I did it originally. Just going to change that to all lowercase, and this POSX I'm going to change to current height. As I say, this is how I did it originally, basically, so I'm doing this because I don't want to confuse myself. But that's all set up, so that's great. It's all ready to go. We'll close this down and we can think about working in here now. So we'll take away this line because we don't need it, and we'll add some more global variables. So global temp height, and these will all make sense as time progresses. And the next one will be global start time, global length, global set speed, so that's our global variable setup so far. And now we also need to open our Python editor, or rather our Expresso editor, click on the Python node, and we're going to add user data. And we need a spline, so we'll call it spline, if I can spell it correctly. And select a spline down here. And we can OK that and then work on setting this up. So let's just see where we are here. So my first point I've actually got here. So if we drag that down to the bottom there, and we can add another point, so put that one in there, and then we can work with our tangents. So the first one I want minus 0.25, or rather the second one I should say, and the first one is already 0.25. That's fine. That will give us the curve that I think will be good for us. So that's okay. That's set up. The next thing to do is to drag this into the editor and set a variable. So we'll say spline is equal to op, and that's all set up for us. So our user data is set up there. It's ready to go. The next thing to do is start to, or basically initialize our expression here. So if we say if frame is equal to 0, so at the start of our animation, we can say start time is equal to an empty list, temp height is equal to an empty list. The same with length. Oops, not curly brackets, square brackets. That's great. The same with set speed. So that's our setup done so far. And then we can say we want a speed variable. So speed is equal to, and it will be c4d.utils.range map brackets, and this will be cpos x. So that will be our input value. And the input range will be minus 94.9 to minus 47.5. So the maximum and minimum heights of our lift. That's our input range. Our output range will be 0, 150. And then we'll say comma false, because this needs to work in both directions. So we need to go from minus 94.9 to minus 47.5 and the other way. So we've got to say false in here. If we say true, we'll only work in one direction and it won't work the other way. The 0 to 150 is actually a time value. It's the number of frames actually that it's going to take to raise and lower our lift. So we're raising and lowering over a maximum of 5 seconds, because obviously 30 frames to a second, 5 threes are 15, so 5 30s are 150, so it's over 5 seconds. That's the maximum sort of time that it can be, but that depends largely on where we are in this range of values. It depends on the position, because of course if the position is above or below, or somewhere above or below its maximum and minimum heights, then the input range is going to change and the output range will change relative to it. So that's what we're doing here. The next thing we can do is start looking at what we're going to do with our buttons. So we can say if button is equal to 0. And for now I'm just going to put pass underneath there, and I'm going to do the same again. If button is equal to 1. And finally, if button is equal to 2. The first thing we'll do is work with if the button is equal to 0. So we'll put the code in that will make the lift raise. That's what we're about next. So let's just take pass out. And we can say here, if len speed, or if len set speed actually, if len set speed is less than 1. So if there's nothing in our list, we can say set speed dot append speed. So we want this value, whatever this, if there's nothing in our set speed list, then we want the current value that's coming out of speed. Moving on from here, we can say if len length is less than 1, length dot append, and this will be a value of 150 minus integer, so int for integer, and this will be set speed brackets 0 double close. So whatever happens to be in set speed, we're going to subtract from 150, which is of course the maximum time that our lift can move over. So if we had, say, a speed of 40, we'll subtract the 40 from 150, because our lift will already have moved to a certain height that will only require 110 frames to actually move it up or down. So that's what we're doing there. We're actually subtracting this from the maximum height in order that the speed is always relative to the height of the lift. That's the important thing here. So that's what we're doing. Okay, moving on from here, we can say if len temp height is less than 1, temp height dot append, and this will be c pos x. So the temporal position or the temporal height of the lift is the current position along the x-axis of the controller, because of course the controller is a null object that moves along its x-axis. So that's what we're doing there. Just take that back a little bit. We can now say if len start time, once again you guessed it, it's going to be less than 1. Start time dot append, and this time it will be frame, because the current frame is what we want to be our start time. Finally, we can say if c pos x is greater than or equal to minus 47.5, current height is equal to 47.5. So that restricts our lift to not getting above its maximum height. So that's what's going out of the output port. If we just open up here, we can see that the current height is of course the output port. So we're restricting that output port to a maximum height, I should put minus in front of that, of minus 47.5. That's all we're doing there. So if it had reached its if it had reached its maximum height, that's what we're going to output there. Else, we can output something else. We can say duration is equal to frame minus start time brackets 0. And you've seen me use this code before when we've done things with range mappers, and that's exactly what we're going to do here. So we can say if duration is less than length brackets 0, we can then say range mapper is equal to C4D dot utils dot range map brackets duration 0, and then this will be length 0, temp height 0, comma minus 47.5, comma false, comma spline. Okay, so in the range mapper then, the duration, which of course will be the length of time that we need to move our lift, it will begin at 0 and it will go to a maximum of length brackets 0. So where we've created this number here, we said that we wanted the time to be relative to the height of the lift. So we're gonna go relative to that height here. So we might have 0 to 30 seconds. We might have 0 to 150 seconds if we were at our bottom. You know, if the lift was right down at the bottom here. So that's how that's going to work. So that's our input range. And then the temporal height, which is of course the C pos X. That's what we said was the temporal height. So we took the current position along the x-axis for our controller. We got that position there. So we're going to go from that temporal position, or that temporal height, down to, or up to, I should say, a maximum of -47. So if it was somewhere in the middle here, it will go from there up to here. If it was here, it will go from here up to there. Or if it was at the bottom, it'll go from the bottom and start working its way up to a maximum of there. So that's how that's going to work. And then obviously the force is in there because we've got minus, well, it's mainly because we've got minus values in this particular instance. And then we've got the spline, which we created earlier, and we've placed up here. So that's how that's all working. The next thing to do then is to output this value to the current height. So current height is equal to range mapper. That's all we need to say in there, because the range mapper is giving us our current height, provided we're not at the maximum height. Okay, so that's what we're doing there. Now, once this is all done and it's got to the stage where we don't need to use it anymore, in fact, I should indent that one. It should actually be under or at the same level as range mapper, because it does belong to this if statement. I can then say else. And at this stage, what we're going to do is reset our lists, because they can all be zeroed out again. So we can say set speed dot clear length dot clear temp height and finally start time. And that completes the code for our button thus far. Okay, so that's the first expression done there. The next thing to do is to set up the code for when our button value is equal to 1. Actually, before we do that, I've just noticed that in here I've spelled frame wrong. Just put that there. That's it. Saves having a syntax error. Okay, great. That's fine. So let's have a look at what we're going to do here with button 1. Well, what I'm actually going to do is copy all of this code and then make some changes as I need to. So let's drop that under there. Let's just see where we are relative to that. Just make sure my indentation is correct. Yeah, that's all correct. Okay, good. Right, so let's have a little look. So the first variable is fine, or this if speed, set speed is less than 1, set speed append speed, that's absolutely fine. Now, this is where we need to make a change in length here. We can't just say length append 150 minus int set speed 0. We've got to do something a bit different. So what we've got to do first, in fact, what I'll do, I'll take this code completely away. What I'm going to say here is x is equal to 150 minus int set speed bracket 0. That's the first thing I need to do in there. I can then say length dot append, and it will be brackets 152 minus x. Now there is a good reason for this, and you'll see it's probably easier to demonstrate it a bit later, and then you'll see what the reason why I've done this. So we'll leave that for now and we'll come back to it a little bit later. Again, this can stay the same. The start time is absolutely fine, and the temp height is exactly the same. That can stay as it is. So those are no problem at all. The C position is where things get a little bit different, and we'll update that. That will have to be minus 94.9. And again, minus 94.9. So as before, this prevents the lift from going beyond its lowest point. That's what we're doing here. So if it's reached its lowest point, we fix it at its lowest point or its lowest height. That's what we can say, the lowest height. Other than that, the duration does need to be indeed the same as before. The range mapper and everything in here is fine. The only thing we really need to change is, again, is this to minus 94.9. And everything else can remain the same. That should all work perfectly well. That said, there is one more thing to do. I just need to put minus 1 in there. Subtract minus 1 from length, bracket 0. This is all to do with anomalies in the way this works going downwards. It doesn't work in quite the same way as it does when it's raised. I don't quite know why this is, but this is something that you do have to do in order to make it work correctly. As I say, I'll demonstrate this a little bit later and you'll see why I'm doing this. Okay, that's fine. And moving on from here then, we can look at our final scenario. So if button is equal to 2, we'll put the code in for that. The first thing we need to do is say if len temp height. And on this occasion, we'll say greater than 0. So if there's something in the list, we need to clear the list out. So we can say temp height dot clear, open, close. And we can then append the temp height. So we'll do that next. So temp height dot append, and we'll append it with cpos x. So what we're doing here, we're going to, obviously when the stop button has been pressed, we need the lift to remain fixed at its current position or its current height. And that's what we're doing here. So we can then say current height is equal to temp height bracket 0. So we're going to output this temporal height to the current height output of the Python node here, and then pass this to the controller's position X, and that will fix it in the current position. Moving on from here, we can start to clear out some other lists. So we can say start time dot clear length dot clear, and finally set speed dot clear. And now everything is ready to be used when we next press another button. And that's all we need to do for button 2. It's a much simpler setup than you need for the other 2 buttons. Okay, so in theory, we've got things finished. And what we can do is just plumb this into the position X of the controller, and we'll see if we've got any problems. Now let's have a look. So for a start, we've got name set speed is not defined in line 24. Let's have a quick look, see what's going on there. Let's have a look. Set speed. Well, we've got set speed clearly defined there, so we may have done something else wrong. Let's have a quick look. It's probably because our timeline is not zeroed out, actually. Because obviously we set everything up at frame 0 and the timeline wasn't at frame 0, so that was wrong. Another thing actually, while I think about it with the frames, let's set this up to 1000 frames, give us a bit more time to see what we're doing. And let's just run the timeline now, and we'll have a look at our user data for the controller. Let's just select that, and we'll just put that in the stop position, and let's just run the timeline and see what happens. So far, no errors. So let's just hit raise, which we won't do anything because we're at the top. Oh, it does actually, we're not quite at the top. So yes, that's raised the lift. And now we can hit lower, and let's see if it starts to go in the opposite direction. Does it do that? It doesn't seem to be, does it? So let's hit the stop button and now try hitting the lower button and see if it makes any difference, and it doesn't seem to do that. So let's just stop the timeline and we'll have a little look and see if we've got any problems in here. Aha, I know exactly why it doesn't work. It's because this should be less than or equal to. I didn't change that. That's why that doesn't work. Okay, so let's just take this back to the beginning, and we'll put the stop button on for a start, run the timeline, and we'll hit lower. And there we go, it works fine. So we can stop, we can raise, we can stop, we can lower, and that works. However, let's just raise up again, and that works from the bottom. And if we go right to the top, we can hit lower, and that works fine. However, if I now hit raise, it jumps. Oh dear, that's not what we want, is it? I can hit lower now and everything is fine. If I hit stop and then I hit raise and now I hit lower, oh dear, it jumps again. So we've got a bit of an issue that we need to fix. So is there a way that we can get round this? Well, yes, there most definitely is. What we have to use is some cunning logic to do this. So it's quite simple actually, but I'm going to put those lines of code in for you now, and we'll get this finally working exactly as we'd like it to, and get it all looking really good. So that's our next port of call, and we'll start by defining a couple more global variables. So it'll be check 1 and global check 2, and we can initialize these here. So check 1 is equal to an empty list, and similarly check 2. So they're now set up and ready to work with. So to finish things off then, we need to add some code. We need to add it within this if statement here, and we need to add it down here. So what we'll do is start working on that, and we'll say if len check 1 is less than 1, check 1 dot append, and we'll just put 0 in there because we're interested actually in the length of the list. So the next piece of code, and this is the key line, if len check 1 is equal to 1 and check, or rather len check 2 is equal to 1, then we need to clear out some of our lists. So this is the key piece of code, as I say. So what we can say here then is if the length of this check 1 is equal to 1 and check 2 is equal to 1, we must have followed raise by lower or lower by raise, because obviously if we press the stop button when we've pressed lower and then we press the stop, we jump down to the code here. So that clears everything out anyway. Because that code at this point is clearing the temp height, it's clearing the time, it's clearing the length, the speed, it's clearing all of these variables or all of these lists, which are variables technically. It's clearing them all out. And we need to do the same thing, but we need to do it here based upon the checks. That's exactly what we're going to do. So the next piece of code that we need to put in is start time dot clear length dot clear set speed dot clear, and we need to say temp height dot clear, and that clears out our main variables. At this point we also need to clear out the checks, so we can say check 1 dot clear, and finally check 2 dot clear, and that is the key piece of code complete. We can now copy this, paste it under the second if statement down here, and then do a few changes. Obviously we've got check 1 in there, we just need to change that to check 2, and similarly here. And again we'll still append 0, we don't need to change anything else. And now, all things being fair, if I've done this correctly and I haven't got any syntax errors anywhere, it should theoretically work. So let's put the stop button on first and play the timeline, hit raise, and we start to raise, and now we'll hit lower, and it works, and it takes us back down to the bottom. So we can hit raise or hit lower, hit raise again, and back it goes. So now it's all working very, very nicely for us and doing exactly what we wanted to do. And of course, if we want to stop anywhere, we just press the stop button anywhere we like, and it works perfectly. Yeah, so everything is fine and dandy, and the code is complete. That's as much code as we need to put in there. Okay, so it's quite involved, I suppose. Well, is it really? I mean, it's simple code, but there's a fair amount of it. I suppose that's what we can say, really. But it's not a particularly complex expression as Python expressions go. But anyway, that's what we need to do to get all of that working, and it's all looking very nice. One final thing I need to do to finish this off is go into my Expresso here, and in the controller I need to select coordinates, position X in there, plumb this into here, and remove the other port. And that just finalizes that. So now I should be able to play the timeline, select my controller and lower, and yeah, the tubing's all working as it should. Great, so that's all looking good. Yeah, it's all nice. Okay, one last thing I will show you. I said that I did things slightly differently within this piece of code to the way I'd done them up here. And I'm going to copy this piece of code here, and we'll have a look at the differences between the two of them. So we'll copy that and paste it in here, and then comment these two out. And we'll also take away this -1 from the length. And let's see what happens when we play the timeline now. We'll just set everything back to the start position and hit the stop button. Right, so if we raise, everything is okay. If we lower, you can see there's a difference in the way that it's working. So we'll raise and then lower here. And look how slow that is. It's really painfully slow. It does work in a different way mathematically for some strange reason. The raise is fine with it, but the lower there's just something wrong. And you can see there it's got to near the bottom, and then it's come to a standstill, and then it started again at a really painfully slow pace. So it just behaves in a very bizarre way, really. I don't quite understand why that's the case, but it is. So that's the reason why I didn't use that in there, and I just played around with it mathematically in order to get things working. And that was the code that I came up with, and that worked quite well, and I just had to put -1 there, and that seemed to fix everything and make it all work okay. So now we've got raise, we've got lower, and yeah, everything is fine, and it just keeps on working fine and dandy. But one of those weird things. I mean, you tell me, answers on a postcard, really. I don't understand why that works that way. I can't really see a logic behind it, but it just does. And it's just one of those weird things that sometimes happen. But anyway, there you go. That's the code complete, and that effectively does bring us to the end of this 3-part series on building a scissor lift. So I really hope that you've enjoyed the series, if you've stuck with it and you've gone through all 3 tutorials, and you've got a lot out of it, and it's been enjoyable for me. I've enjoyed putting this together. But anyway, that does complete the series. So as I always say, if you've enjoyed the video, then please give it a thumbs up, and if you haven't already, please subscribe to the channel, and of course leave a comment and ring the bell. And wherever you happen to be on social media, then please share this video and many of the others, because all of this good stuff helps to keep the channel moving in the right direction. But anyway, that wraps this one up, so I'll see you very soon on the next tutorial.